Hello everyone, myself Geeta. In today's video, we are going to see about integration. So before looking into integration, what is integration all about? Integration, we would say that it is a reverse process of differentiation. Reverse process of differentiation. What is differentiation? What do we do in differentiation? Differentiation, if I have to say what is differentiation, then I would say that I would be given with a function, and then for that function, I would be finding out the gradient. This is what we do in differentiation, gradient or slope. We find out. But under integration, it is a reverse process, means I would be given with a gradient, and then I will find out the function. That is what is all about integration and differentiation. So now how to find out a function when gradient is given. These things when we are doing problem, you would able to understand. But we have few things which we need to know the terminology wise. So first thing which we are going to look into is primitive or antiderivative. So how this integration came from these terminologies is something which is very important. So now let's look into primitive or antiderivative. So, what is a primitive? It's connected with a very early stage. That is what we call it as a primitive, which is connected with the early stage. We call it as a primitive. Antiderivative, if it is not a differentiation, derivative means it's a differentiation. Antiderivative means it's an integration. All these are the same thing. But we are using these terminologies, so how the integration came into a picture to just for that reason. Suppose I have a function phi of x, and I consider this to be a primitive or an antiderivative or an integral of a function f of x. And if phi dash of x, the derivative of phi of x, is equal to f of x, only then I would say that it is a primitive or an antiderivative or an integral. So function phi of x is called a primitive. A function phi of x is said to be a primitive or is called a primitive or an antiderivative or an integral of a function f of x if my phi dash of x is equal to f of x. What does that mean? Let me give you a simple example. I have x to the power 4 by 4. Okay. And this is a differentiated one. You would be able to understand. Like it is not a differentiated one. If this is gonna be, what I meant is, if this is gonna be a primitive, let me just put it, okay, is a primitive of x cube. Why do I say that? That means when I differentiate x to the power 4 by 4, what I would be getting is 1 by 4 is a constant, I'm taking it out, and x to the power 4, when I differentiate, I would be getting 4x cubed. 4 gets cancelled, and I get it as x cubed. Hope you understood why did I say x power 4 by 4 is a primitive of x cubed. Okay, now let me just give you one more. See here, before going into an example, let me just conclude and then go with the other one. So something if I have d by dx of one more example. Okay, let me finish it up. X power 4 by 4 and then minus 2 if I have. Now in this case, when you differentiate, what you would be getting? If I'm not wrong, you would be getting same x cube. You differentiate it. When you differentiate, you would be getting 1 by 4 into 4x cube. And when you differentiate minus 2, it becomes 0. And 4 gets cancelled, and you would be left out with x cube. Same thing happens when you differentiate x power 4 by 4 minus 1 or plus 1 or plus 2 minus root 3. Whatever it is the constant. But x power 4 by 4 should be there and followed by those constant. You would get your answer as your x cube. So let me just conclude something. So if phi of x be a primitive, it's gonna be a primitive of a function f of x, and let c be any constant, then I would say d by dx of, just don't, by looking at it, don't get afraid. I will just explain it to you after this. Phi of x plus c is gonna be equal to phi dash of x, which is gonna be equal to f of x. See here, phi of x plus c. This phi of x plus c is nothing but x to the power 4 by 4 minus 2 plus c is going to be minus 2 here. Or if I say plus 1, c is going to be plus 1 here. Whatever it is, after differentiation, I would be getting that. And which is going to be equal to f of x. So from this, therefore, what I would be saying that phi of x plus c is also an antiderivative or primitive, is also a primitive of f of x. So you are able to, I think you would have understood by now, there are infinitely many primitives are contained in this particular process. So that's the reason we introduce a constant c. Okay. So let me just put that. It was so in this process when you would have observed we have infinitely many primitives. Let me take a simple example and then explain it to you once again, which are contained in the expression. Contained in the expression phi of x plus c. The c is a constant. C is a constant. Okay. Let me just give you one more example, so which I think you would be finding it very easy to understand. Let me take a very simple example. I'm taking a function y is equal to x cube. Okay, what is gonna be the gradient of this particular function? So it's gonna be 3x squared is gonna be the gradient, which is nothing but dy by dx. Okay, so for y is equal to x cube, this is gonna be the gradient. Y is equal to x cube plus 5. Also, this is gonna be the gradient. Y is equal to x cube minus 9. For this function also, 3x squared is gonna be the gradient. Y is equal to x cube minus 3 by 2. For this particular function, also 3x squared is the gradient. Y is equal to x cube minus root 3. For this particular function also, 3x squared is going to be the gradient. So in this way, how many functions you can write for which the gradient is going to be 3x squared. So our answer would be like infinite functions are possible for which the gradient is going to be 3x squared. The same thing has been explained above with a term primitive, and and that's the reason plus c they are using, because for us the common thing which we observe everywhere, if you would have seen in each and every function whatever I have taken here, x cube was common, but the constants were different. without a constant. Here x cube, no constant is there. Or x cube with various irrational or real, some or the other real constant, real number was there as a constant. But in all those cases, my gradient was 3x squared. My gradient was it was not disturbed itself. It was as it is. So how many functions are possible for which the gradient is going to be 3x squared? The answer is going to be infinite functions are possible. So in this case, what is happening? We are finding out indefinite integral. That means we are not sure about what is going to be exactly the function, but we are sure with that the like one of the family. It comes under one of the family of this. It can be a cubic function. It comes under cubic family. X cube. Like we are making it sure. Not exact sure, but we are making it sure it comes under this family. That's how it is. So we would be looking into indefinite integral. So let me just give the definition and then next we would be looking into the problems, the formulas, everything. So the concept which we are going to see right now is indefinite integral, and then I will proceed with the problems in the next video. Indefinite integrals. Let me just give you the definition. So f of x is a function here. F of x is gonna be function, any function. That's the assumption. Then the family of all primitives. I mean x cube plus 5, x cube minus 9, x cube minus 3 by 2, x cube minus root 3, all of this. And there are infinite. So the family of all primitives is called indefinite integral. Indefinite integral of f of x. And it is denoted by integral f of x dx. Now, when I'm saying something, this is a symbol which has been used, right? So this symbol is read as this is indefinite integral. Okay, so that part we would be sure, and this is gonna be integral sign. Integral sign. German mathematician Leibniz introduced this symbol. He introduced this symbol. He considered actually it is sum of infinitesimal. Actually, what has happened is Leibniz, when he introduced, he is like infinite sum of rectangles of infinitesimal width. Actually, we would be using integration to find out the area under the curve. So what he did, he picturized lots and lots of rectangles, infinite rectangles. So the sum means we would be using summation. So so in order to that, so a lot of summations were used. So what he did, he introduced there was a word summa in and in this which means sum, and he used that yes as an elongated s, and which is an integral sign now. That's what. And here this f of x is called as integrand, which we write inside. It's called as integrand, and this dx is a differential of x. It's called as differential of x. Differential of x. And the x is a variable of integration, is the variable of integration, and dx is the element of integration or differential of integration. You can use it as differential of x or element of integration. anything, element of integration. So the process of finding an indefinite integral of a given function is called as integration of a function. Okay. So this is all what is all about indefinite integrals. So f of x is a given function. Then the family of all the primitives is called as the indefinite integral of f of x, and it is denoted by integral f of x dx. And what this sign is the integration sign, and then f of x is f of x is the integrand, and x which is there inside this one is a variable of integration, and then this dx is called as element of integration. Hope you understood. Now in the next one we will start with the indefinite integral problems. Thank you.